In this video, I'll show you how to solve the ALEKS problem called Understanding How Molecular Collision Rate Scales with Temperature and Volume. There's a lot of numbers in this problem, but good news, we don't actually have to do any calculations in order to solve this problem. We've got 4 different samples of gas, and it does tell us here that every sample has the same quantity of gas. For mine, it's 0.7 moles, and it doesn't matter what that quantity is. You don't have to worry about it, but what matters is that they all have the same quantity of gas, and that means that this problem is going to be super easy to solve. So we're being asked to rank these samples of gas based on their frequency of collisions per second, how often the gas molecules are colliding with each other, and we're going to be doing this by evaluating the volume and the temperature. And I think it's easiest to start by evaluating the temperature. That's what I recommend you start with. So look at the temperature first, and what we know is as the temperature goes up for a sample of gas, so the higher the temperature is, because the gas molecules are moving faster, that means that they are colliding more frequently. So I'm just going to write more collisions. They're colliding more frequently, again, because they are moving faster. So the higher temperature gas, the gas sample with the highest temperature is going to be the one that has the most collisions. Now you're going to see that there are a variety of temperatures. You might have a few temperatures that are the same, but there is going to be a variety of temperatures. Find the one that is the highest. That's going to be the one that's having the most collisions. Be careful. I have all kinds of negative temperatures here, so don't just immediately say, oh, 135, that's the biggest number, that's the highest temperature. These are negative temperatures. So this is actually the coldest sample of gas, which means that this one, this is the lowest temperature. This one has the least number of collisions, and ALEKS is calling that a 4. And then this is my sample of gas that has the next lowest temperature, so that's going to have the next least number of collisions. That's going to be a number 3. These two have the highest temperature, which means that they are the ones that have the most collisions. One of these is going to be the number 1 most collision, and the other one's going to be number 2. So I don't really need to look at these anymore because I've already got those ones sorted out. And now we need to take a look at sample B and C and distinguish them from each other. And to do that, I'm going to use the volumes. So the volume, obviously that's representing the amount of space that the gas occupies. And the smaller the volume is, the closer, because all of the gases, remember, or all the samples, they all have the same number of gas molecules. So the smaller volume, that means that the more dense the gas is, or the more packed in it is. If I've got 7 gas molecules to fit in a small volume versus a large volume, I don't know if I actually made 7 dots there or not, but you get the idea. These guys are going to be bumping into each other a lot more frequently because the volume is smaller. So the smaller the volume is, the more collisions we have. And so for these 2 samples of gas, both at the same temperature, the one with the smaller volume is going to be the one that has the most collisions per second. And then this will be number 2. Now you can start ranking your gases with the volume if that's more comfortable for you, or if that works better for the data that you've been provided. What I recommend that you do is pick one variable, either pick the volume or pick the temperature, sort things out as much as you can, like I did. I was able to identify the least and the next least. And then when you get to a spot where you have a tie, then you can look at the other variable and help you break that tie. Notice that I didn't use the volume of sample A or sample D at all in this problem. It wasn't important because I started by ranking them, and I was able to, with temperature, and I was able to do a lot of the ranking based on temperature. Good luck.